right, let's get to it. Grab your beverage. Take a seat. Grab some food. Right, beverage in the way here. Welcome to the teardown portion. Welcome. We have remote viewers as well, so welcome for those dialing in. I'm super excited. As I mentioned before, I'm Tobias. I'm just here to MC. These two here, joined by Will and Molly, they're doing the real work. We'll do intros in a second, but a little lay of the land. Questions, we need your input throughout, so questions, just throw up your hands. We're just here to do the hands-on work. Really, this is meant to be a collaborative, knowledge-building session here. So, what are we tearing down? You may have seen it here. The Amazon Alexa Echo Show 10, I think. Oh, you see that?
Those are names.
And I think she actually, we'll try it out here for a second. I think she actually follows me. Alexa, follow me.
Following is not on.
Oh, yeah, there we go. All right, so creepy or cool? What do we think? And so I think they knew the same thing, so they designed in a little shutter to turn off the camera. All right, so why did we pick this? Well, it has a lot of different interesting design elements. We have the entire display on the front, it's basically like a full tablet. It's got a speaker and it has a rotating base. So it's got a little bit of everything. And I know a lot of you guys may have worked on similar components here, but I actually want to take a quick poll. I think probably speaker is the most common. There's been a lot of these devices here. Who here has worked on a device that has some type of speaker in it? Speakers all around. All right, a lot of people. Speaker and display. Keep your hands up. Hands up for now. All right, keep them up. We're down to about a half. Speaker and display. Speaker and display and motor. All right, I see some people kind of thinking like, does the body motor count? Depends. All right, so that's why we picked this, because we get a little bit of everything. So, without further ado, let's introduce the team. Let's start over here with Molly.
Hey everyone, I'm Molly. I kept my hand raised because I worked on the Jibo robot. Anyone ever heard of that? Oh, I got some yeses. All right, cool. Consumer robotics product in function, very similar to the Amazon Echo. I would argue a little bit cuter, 3 degrees of freedom. But yeah, my background's in mechanical engineering. I work here at Instrumental as a solutions architect. And with that, I'll pass over to Will.
Hey everyone, my name is Will. I'm also a mechanical engineer. I used to work at Apple, and I've worked on a range of different products from the watch to some Mac desktops. And this is my first change on this, so I'm pretty excited to be here today with you guys and lead your game of bingo.
Yes. I hope you guys all got your little bingo sheet. Everybody hold up your bingo sheets. All right, we got it. Everybody have pens too. Did we get those out? Yeah, good to go. All right, I'm Tobias, also mechanical engineering background. Spent a number of years at Apple, phones, watches, and been here at Instrumental for about 3 years. Currently leading the partnerships. So let's talk quickly about bingo while Will gets ready here. Does anybody not know how to play bingo? So as we go through the teardown, you'll see these various squares. Check them off when you see them. You can call them out if you want, but you might want to keep it to yourself. Check them out as you see anyone find one of these different features, and you get 5 in a row, any direction. You got X's, you got a cross. Yell it out, yell out bingo, raise your hand if you want, and our lovely marketing team, Kristen, somebody will hook you up with special prize. It might be in the t-shirts, it might be an iFixit kit. We've got a lot of options. Question throughout, throw up your hand. You need your input. The whole goal of this change notice is to build a community for knowledge sharing. And this is a special, not only since the first in-person, I think this is number 21. Change notice is turning 21, which is why we had a happy hour. Yeah, we all found this here. All right, so let's get to it. Will, you want to kick us off with a little overview?
Yeah, this was a really interesting product, as I said, with a lot of features as I first looked at it. It's basically like a whole tablet on the front. We got, volume buttons, power buttons, camera shutter, and then a pretty typical kind of home hub speaker design here on the back. You got your nice mesh, power port on the bottom, and then this big beefy hinge. And one thing, as I move it around, you can see the thing rotates really smoothly. It's really nice. But when I was playing with it, and you actually touch the touch screen, it somehow kind of locks it up. So I'm pretty excited to open it up and see how they enable that. So, that way when you're touching it, it doesn't just rotate every time you tap on the butter. So to get us started off, I'm gonna take off the back here. I know this top piece pops off, and we'll get into the guts.
Shout out to that iFixit kit that we have laying around.
Yeah,
iFixit.
All of
it. Where did he go? Thank you for all these kits that we have over here.
Yeah, we'll have a whole suite of tools, all brought to you by iFixit, from our prying open to our custom screwdrivers here. But when we open it up, first thing I see here, we have our plastic top, which is just held on with some adhesive, so that pried off pretty easily. We've got a huge speaker here, nice big subwoofer, big beefy hinge, a lot of mechanical stuff. And next thing I'm gonna have to do is take out these green screws. That looks kind of fun. I've never seen green screws in a product before. Molly, have you seen something like that?
I actually have, but let's see if the audience has any ideas about why there might be green screws before I go with my ideas.
Green screws, colored screws. Anybody? I see some people looking down at bingos.
In the old days, green screws indicated a third ground.
That's
That was my first thought too. Is like you're putting in the electrical plug, you have the green screw.
Probably not.
yeah.
Right, so it's over.
Green screw. All right, electrical grounds. All right, some type of locking feature. All right. Anyone else? Green screws. Optical inspection. Ooh, interesting. All right. Like an automatic inspection, is checking for the color. Yeah. That's an interesting one. But what do you think, Molly? What was your experience?
My experience at Google, we would actually color code all of our screws. So every set of screws would be by function. And I think that's what we see here, right? They're not all green. Well,
we also got some black screws. Yes, we got green and black to start. So already two colors.
I was the lucky one who got to choose what color each function was. Pretty fun job. Probably the best part of being the screw DRI. Yeah. Yeah, so you make sure like this station's only going to have the green screws ever. If you see a blue screw here, you know it's wrong. And then when it goes in, you know that you didn't get the wrong length of screw as well. It's really quick visual check. So I think the automated inspection was probably along the right lines.
So it's the dummy proof.
Dummy proof.
Yeah.
Yep.
I have seen the blue, the little blue coating. That's probably the Loctite. That's meant to be bad. And there's the different colors. Yeah. What did they? Who knows all the colors of Loctite? No, it's green, red, purple. Which one? Red is. Which one's the strongest?
Yeah, I think red might be the strongest.
Red,
yeah.
Red is aggressive, blue, and then green's like the loosest one. But
Like a nice rubber foot there. This one's kind of interesting because it's actually, I think, formed a little bit. Like pretty beefy, probably for this big heavy speaker.
Yeah.
Oh man. And
What do we have on the bottom? Can you try to get it under the?
yeah, you can see under here we got our power jack. It's kind of weird. I don't see any other communication port. I wonder how they test it. Everything I've ever taken part has like USB-C or something to actually talk to the device. Oh, there's the power barrel. Yeah, just a little barrel power cable here. You got the standard.
Yeah, that's a good question. Now, have you guys seen where do you guys think they test this device? It's just a power port, so there's no external port that we can see here on the bottom. Yeah. I know the Apple Watch for the longest time. They had the little ports underneath the band, slide off the band, and they have like 5 little diagnostic ports. And I think they might have gotten rid of those recently for a wireless test communication. Any other ideas? Wireless. Wireless or pogo pins. Comment from Zoom. What we got?
Eric Wynn thinks there's a diagnostic port and then diagnostic port after the year.
All right. That is awfully specific. I was feeling
Look at that.
Hey!
We got a little, some oldness.
Eric gets a
Better
t-shirt.
tell me you're driving the office.
Your wage right there. Also for you bingo folks out there, we got some silver screws. And I pulled out the power drill because this one's got a pretty beefy head and some thread forming threads here. So these are just real tight, holding the whole base together. But I told you this thing is pretty heavy, so they'll have some pretty heavy screws to make sure it all stays together. But I had to take a lot of pieces off here to get all the guts out. We got the top, we got this nice cosmetic thing here. And funny is, this is not actually circular. It looks like a circle, but when you take it off, it's kind of just weird oblong shape. But there's tons of screws.
So we've got the speaker, the motor, and the display. What are you guys most excited to talk about and look at? Because we got to prioritize time here. Speaker, display, or motor? Or anything else that you want to make sure we cover? And you want all of it?
Motor.
Motor. Ooh, motor. All right. Right. Go for motor.
I'm noticing this as well as first time joining, and I think also our first time having power tools.
Yeah. I'm not noticing a correlation there.
Yeah.
And we should definitely get those electric screwdrivers that they have in the factories. All right, we're making some progress here. More green screws that were under that plastic piece.
That hinge there, the hinge looks pretty beefy compared to what I was expecting. Why do you think that hinge is so beefy?
Yeah, I mean, when you move the display here, it's pretty strong. It really holds up the weight of it, but like I said, with the rotation of it, it's also a touch screen. So imagine just like you don't want it to rotate, you don't want it to tilt every time you tap on it. And we are on the road here. Oh, yeah.
Nice.
Now we got some guts. First thing I noticed here, we got 2 tweeters, some little speakers here. We got a PCB tucked under the bottom here. We got our power jack, another PCB here on the motor controller. There's another sneaky one in there that might be part of the motor. Wherever you have 4 PCBs, 3 speakers, and a big hinge. So let's dig into that.
Should we get a close up? It's kind of hard to see under the rotating there. Do you want to get a close up in instrumental?
Yeah.
Sure. Do you mind stopping sharing?
There we go.
Perfect.
See if I can get down to the motor while you dig in there.
All right. So this is our close up. We're looking at what I would assume is probably like a main board here. If I zoom into this board, I'm noticing some foam wrapped cables, probably imagining a lot of rub and buzz kind of issues with a product like this. We also noticed something really interesting here, which is a vertical ZIF. Has anyone used a vertical ZIF on a PCB? No one. Yeah,
Me neither.
me neither. The latch kind of rotates 90 degrees. Pretty interesting, but why do you guys think they chose to use a vertical in here?
That's some idea. Why would you use a vertical zip? So it's just the flex. that typically goes in horizontally.
Real estate.
Real-
I got a tight board and I went for that. Horizontal.
So actually, you're thinking XY real estate? Yeah.
Always component from all. Side.
Yep, just overall component layout when we're
Already
looking
to
to
like
the
the castle very well, like.
Yeah.
We're probably all for these homes.
Yep.
We're looking at this Saturday.
There's also common maybe some of these meetings.
Oh, yeah. I mean, it would be pretty quick to bend over. Typically, I've seen when XY is the primary constraints, they'll use a board to board, a little bit taller. The ZIFs are really good if you're trying to get thin in Z. And so that's kind of the trade-off. I've never seen a vertical ZIF sneak in like this.
The other thing I noticed that was kind of interesting is this unstuffed component here. So I'm noticing they still put the solder down on these pads. I'm curious for the audience and for you guys what you think. Why might you do that? Yeah.
Those have to talk with work and they originally designed for 5 or 6 wheeler on the power line. And the motor control, they realized, well, we get by with one less. So it's a no stuff.
And so that's a design change afterwards, and then just left the pads.
There's 30 cents on the way.
Kind of vertical zip. I don't
Talk about them later on. But they left the pads there.
Yeah, I'm not going to spin the board when I'm leaving on stop incurring another risk.
Yeah.
We can't do that.
I agree. Why do you think they left the solder on top of the pads?
That's because either they, didn't want to make it successful. I don't know. That's what it looks like. So stream.
Yeah.
You think maybe there's different SKUs that they sell? Could be like a different region, a different power. That's an interesting one. I heard corrosion. That's what I had a thought as well. I know why. So why do you think it would help with corrosion?
Right.
Nice. I think it works, but you have no idea why. That makes me think of Anna's quadrants. In the lower right, it's working, but you have no idea why. I've heard the first thing that I thought was corrosion. I believe a lot of the copper that's exposed, at least back on the fluxes that I worked on at Apple, there was a tiny little gold plating, like a couple microns thick. The gold plating was prevent corrosion, but I think having solder on top also reduces the exposed copper. So it could be corrosion, could be that it's more consistent on top. But. Ooh, yes. Great question. Quick summary of all the great discussion. Let me just back that up. We have unstuffed components, speculation around corrosion being the reason why there's still solder on there. They didn't want to change the stencil after they unstuffed the component. And unstuffed component probably either cost reduction or maybe a different SKU that they removed the component but still left the actual pads there.
Yep.
All right.
Some other things I'm noticing here, we have some Sharpie marks on these screws, maybe kind of the poor man's green screw. And we also have some black glue here around some of these taller components. I think this isn't too tall. It does remind me though of another teardown that we did, the Sonos One. So let's take a look at that for reference. When we were looking at the Sonos, we were looking at, there we go. Here we saw big globs of glue. that kind of went all the way up to the very top of the components versus the pretty thin layer of black glue. So yeah, why do we think there's such a difference?
Big globs of glue. What do we think? We have one vote for Sonos is using hot glue here, which is bleeding bit.
Often I've seen as stability in these of the part 75. Like the black rule, I'm not too sure. Usually you like connect all the halves to each other. Yeah.
So for the online folks here, giving you guys special attention now. There's some speculation for tall components need more support for shock and vibe, so that's why there's more glue here. Shock and vibe seems to be. So why is it so much more critical and so much more glue in the Sonos than the Echo Show that we're seeing here? Any thoughts? Taller components. What do you guys think? So Sonos has a taller capacitor, so you just need more glue.
Definitely noticed, this has got an adapting wall because of given DC power. And I think there's, some primary power here because the Sonos won't clutch the wall. So there might also be some safety reasons to have to insulate all those 120 volt traces and leads on the board, especially with the big, huge ones with all those wires sticking out. It could be kind of a safety issue too.
That's a good thought. Good. One more.
I enjoy the higher standard for shock.
Oh.
Very here. Relax the petrol so they never get it to ship.
Shout out to the reliability folks in here. Change the standard a little bit. Yep. Comment there was on what the different reliability standards that each product is tested to, which is very valid. That can influence the design.
Yep. All this glue personally makes me pretty nervous, feels a little uncontrolled in both of these situations. So thought I would just kind of flip over here and show you guys a quick demo of what you can do with instrumental to make sure things like glue are in a more stable process. We're operating in the right quadrant where we know, why we're doing well or why we're doing poorly. And so this is an automotive previous customer who was actually doing some potting. And so I'm going to zoom in here to this place where they were doing that potting operation. And what I can do really quickly is just select a region and say, I want to see what this area looks like. And I actually want to see the most anomalous. I could choose the most similar. If I'm looking at one that has these voids I really want to avoid, then I could go ahead and say, let's look at the most similar. But in this case, I'm actually looking at the, just what are my weirdest looking potting areas. This is our cute little robot, Norm. And he comes up with this. So we see, I'd say kind of overflow of potting. We see, in this case, this is actually some debris that shouldn't be in there. And really quickly, we can see every serial number that, I may want to go and actually check out this specific serial number. I can go ahead and actually push something back to the line. So I make sure in the future, we're in good, very stable operation. With that, I think I will actually pass back to Will. Are you ready to talk about?
I've been busy.
You've been busy. All right, let's see
Let
what
me
you
show you
got
guys
here.
what I got here. Went through a lot of different screws, the whole module here. Found this little motor board here and had a interesting little compound pin that stuck over the edge. Curious to find out what that might have been. From above here, I found the motor underneath and all the mechanical bits, some kind of cowling. We have a C-clamp ring. We have a little washer here that looks like it's Teflon plated. Another spring washer to preload his bearings. Nice big beefy bearing here. The other one underneath. A full mechanical assembly here, and then a ring of magnets, and then our motor here, which looks pretty fun. Got a ton of different coils, which is I've never seen a motor with this many coils. I think it's like stepper motors or something from school projects, and they usually have 8, 10, maybe 12 coils. And
Why do you think there's so many? Why do you think there's so many there?
yeah, if I had to guess, it's probably related to the step size. Yeah, exactly.
Yeah. Smaller step. We're hearing some smaller step sizes from the audience.
Does anyone have experience with motors? And how would you put this many coils on a motor?
Really bad.
Yeah, pretty impressive mechanical assembly here for consuming electronics.
I know. Well, you were also mentioning when you're tapping the edge of the display, because this is a touch screen, it could actually rotate the device. Do you think does the number actually correlate at all to the holding force and the torque, so it prevents the rotation?
You know, now that you mention it, the amount of wiggle it had does seem to be about the size of these gaps. So maybe it's just more coils they could squeeze in, and only they could kind of hold it in position. And so they probably had a fun design challenge there, optimizing for as many coils as possible without making this cost $10,000.
How did the power actually get down to the rotating base there? I see that funky flex.
Oh yeah,
kind of stitched right up there.
this is, you know, your spaghetti flex, which you find at least one in every product in my experience. But yeah, I was wondering the same thing. It's all coiled up. It's got multiple free bends going on in vertical lift. And I think this was a key part of how they were able to have it rotate without actually losing power. Well, I know you looked at that, right?
Yeah. I would love to share a quick little video if we. I know Anna mentioned video streams, so everyone here is going to be able to be some of the first people to see this live in our app. We, right alongside all of your images, your functional test data, you can also go ahead and view videos from your manufacturing line. In this case, we were just trying to show off how this flex moves as it rotates. You can see it kind of enlarges and then coils back up. Pretty interesting. In my experience, like the Jibo robot used a slip ring. So it's basically like concentric areas that were conductive, and then I think like a pogo pin or some sort of similar spring-loaded piece that was dragging across those areas. Could have thought maybe this would just be like a standard cable, like Molex or something, because all this is carrying is power, right?
Yeah, the only thing it connected to was that power jack. So I guess it's just the power coming from the wall to get through, but pretty complex way to route that through your whole assembly.
Has anyone else had experience with rotating electrical connections? Rotating? Oh, all right. So I know. What method did you guys use for the rotating electrical connection? Like, was it just like a standard ribbon cable, a flex? Was it similar where you had to design extra service loop to account for that? All right. For the online folks, lots of cycle testing and extra service loop.
Yeah.
So flex, any other?
Cable. Great. Wires and purposely. Even there. One of the higher.
Yeah, so ribbon cable, extra service loop, but it still failed. Oh, just like a twisted. All right.
All that power in each end.
Yep.
Wires. Oh, flex. In that cable.
Yeah.
Only one.
Yeah, this one goes almost all the way around. Does anyone else have experience? The most recent one that I had was back working on the Apple Watch for the newer versions that have the ECG on the crown. Anyone have any idea? Because there's no hard stop there, just preventing go 280, and there's an electrical connection. Anyone have any idea how that connection's made? We've got slip ring as one option. Any other thoughts? It needs to actually make, there's a question about an encoder. The encoder is to sense the rotation, but the ECG sensor actually makes electrical contact with the finger. And this was actually one of the things that I remember working on. And it's actually, it's not quite a slip ring around the diameter. It's a point contact. It's a single point of contact with a lot of conductive grease. You got to get the conductive grease because otherwise it's going to wear down over time. And the signal on the ECG is super low. You know, the overall signal in your body is super low, so it's really sensitive to any extra noise. So I remember there was a huge pain. Same sort of thing, cycle testing to you know X number of rotations. Still at the limits, there's still issues, but yeah, rotating electrical connections, not easy.
Yeah. All right.
There's a question around how do we maintain the grease? Yeah, well, let's get back to the teardown. There was enclosures around it, mostly stayed in. That's grease goes.
Yeah, I'm glad I have this high fixie kit. I have to get a bulk for the distribution. But finally got our 3 core components here. Our speaker module, the speaker power board, we got our motor assembly, and our display. Before I move on, does anyone have any questions about motor? Anything you want to see more detail? How many poles? Like how many of these coils? Like these guys? Yeah, this was definitely taken to my tool.
I just want to repeat here. What
question?
Yeah, repeat the question was around what is around the exterior.
Yeah, so there's how many poles there are.
Oh yeah. How many poles there are on the magnets around the exterior?
You know, I don't know the orientation, but it looks like they might all be the same. But it's hard to say without another magnet. But there's a lot of them. More than there are coils. So there might be 2 for each coil.
That motor was pretty standard off the shelf. We needed something pretty customized for this product.
Oh, to me, there's no question. It's just how nice. Yeah.
Question was around standard versus off the shelf.
Good question.
Other questions as we continued here?
As I was working through towards the display, I'll get in there in a moment. I also noticed this guy on the foot. And there's a little plastic piece on the foot. And there's this little sticker thing here. It kind of looks like a circuit, but it doesn't connect to anything. You ever seen anything like that?
Can you hold it up a little bit? What is?
Is that like RFID?
Might be. Like, why would you put that on your computer?
Let's see what we got from the audience first. I've got one idea.
What do you think, Dave?
Yeah.
I would, think maybe it's going to run the line without putting silver on the outside. Because that's not really long for product. For the outside or the inside. It's not professional enough.
So serial number without having to put a cosmetic label on the outside. All right. And anyone else? They're becoming sentient, so it can notice other devices. I think you're going to need a little more power, but you never know. I think it's got to be some type of identification. Chris has an idea over here.
So Amazon is known for logistics
So when they go through the, fulfillment center, maybe dependent, you, the packaging model to, know which serial number, which device is going to turn. Perhaps,
That is really interesting. So Chris was saying it's potentially an RFID tag used in the warehouse instead of during manufacturing, either to improve logistics or personalization. That's an interesting one. I think you might be onto something there. I originally thought maybe it was a serial number replacement, but I find it hard to believe that they're going to spring for an RFID tag just to replace a serial number on the inside of a part. It just seems too expensive for this type of device. So I'm leaning towards some type of fancy logistics. Which is pretty cool. I haven't seen that in other devices. Has anyone else seen RFID tags? Yeah. Specifically for the motor subassembly. Yeah.
I will say when I unboxed this, the first thing it did when I turned it on was it say, "Hey, Will," and it knew where I was. So I don't know how they do that, but if that's what it takes to do that personalization, they figured that one out. Again, creepy or cool?
We're gonna take a look. Let's. I want to do a bingo check here. How close does anyone have 3 in a row?
Are you done?
Whoa. Wait, okay, that was 3 in a row. Does anyone have bingo? We have one. Oh, you're holding out on us today. All right, we have the first one. Don't worry, there's more prizes. How many people have 4 in a row? All right, so we got a lot of us. Oh, that's true. Ryan's gonna double check everything. Oh, was that a bingo? Accidentally drops the bill.
It's just fun if I break something, right?
Yeah, if you get the 5, the 5 call it out. No influencing the direction for your bingo card. All right, let's keep it going here. If there's anything specific you want us to dive into, let us know. We're getting down into the display right now.
Yeah, finally pops the bad boy open. I'm crying.
We have
Oh,
a,
wait, we got a question. Oh. So the question, the leading question is, would we say that the mid famous? I would throw that back on you. If you can make a rational argument onto why it's cast, you could have a bingo. I would say yes. That's
there's a
mid-frame.
back cover, there's a display, yeah.
It's in the middle of a couple of things. Yeah, I would call that the mid frame.
I may be able to help with a clue. Where,
Yeah, survey says.
I can actually jump into the app here and show you what I'm seeing when we look up close.
You need to stop sharing here. Yeah, this will be
Alright.
the determination for bingo winner here.
What does this say to people? A360R. Any- so I looked this up. We thought initially maybe it was mag, but it seems to be an aluminum alloy. But I think it is a cast aluminum mid-frame. So does that mean we have another bingo? You can say that.
All right. 3, 4.
All right, let's see what else we can see here. So let's take a look up here. What do you guys think this is? Kind of a big flex here, with a chip on it. I hear a touch flex. Tobias, Will, what do you guys think?
I mean, there's 8 different flexes here, so.
Why, yeah, so, could be, I'd like to hear why do you think it's a touch flex? Where did it go? Alright, touch controller on the flex. It does look like, so Will, are there, or Molly, I think that might be the only flex that has a big chip on it.
Yeah,
right? And if you zoom in on that actual flex there that we're looking at, does that bend, where does that top bend go?
yeah, I think it goes through this plastic frame. So,
Maybe Will, if you peel that flex up, we can take a look. I think you might be right. I think it's actually the touch flex because that's the one, in my experience, that needs to have the controller close to the panel.
Oh, can you, help us share?
yeah.
Let's see if we can get a closer look there. If you saw me here, this one's really hard to unplug. Certainly not easy. Just to share a few things I saw as I was getting through here. Finally got this hinge off. Pretty beefy. And attached to that hinge was the fun little flex here that we were talking about earlier. And you can see these little contacts here. So our theory was that was instead of a USB-C port that allows it to communicate from the outside. That was pretty cool. I've never seen anything like that. But getting to our flex, any little fragile flex. I got this big shield pan off. And it's just a small little connector, so it's a few little digital lines. If I can find any other information on it. It looks like it goes down to the display, so that's it.
Right.
It could be the display flex.
This is, for you guys, so we can confirm if this is the touch and you guys can check it out. I know some of you guys already checked off the touch flex.
There, this is crazy piece of it there.
Oh.
I like that. The extreme conditions that the Amazon Echo needs to survive.
Any clues on the back side of that flex wheel?
Nothing I can see here. I got a bunch of electrical grounding adhesive here. But it does, you can see a big fat part of the flex over here going down laminated to the display.
Yep.
So taking a look at this one too, this is probably more likely to display flex. I would say if you go that, that's the touch flex.
All right, we have a touch flex. Check it off. I can see. What about, Molly, do we want to take a look at, I see like a whole bunch of antenna cables.
Yeah, let's take a
Why
look.
are there so many antenna cables?
Yep. All right. So we see kind of starting at the bottom here. I see this one. If I zoom in, I can see this one's BT. So get probably Bluetooth here. If I zoom into, we got a really long board here. And if I zoom into that one, I see WF, so Wi-Fi. And then this one, we've got one more up top. And this one is LZ. Anyone got any idea what the LZ antenna might be? Yeah, it stumped me too. I don't have an answer.
I'll see, I heard some mouthing over here. Low impedance.
I actually did Google LZA antennas.
Yeah.
It's a Eastern European TV antenna company. Big wire ones that stick out in like a grid.
Yeah.
But I'm thinking that might be unrelated.
Thinking possibly unrelated.
So one other thing I thought was pretty interesting with the antennas here is this region looks kind of symmetric to this one. And we even can see kind of coming from there, you can imagine this would be another one of those clips, as would this then we keep following. That theoretical antenna would keep coming this way. And wow, there's even a place for it on the board here.
Yeah.
So which antenna do we think got lost here? Maybe this is a skew as well.
Maybe they just go.
Similar to that.
Yeah.
There's a lot of extra fit with it.
Yep.
Yep, answer here, they tested more after production and they changed the design because it was not needed at some point in the future.
It's like DEP that they would have cleaned up for whatever reason they it's close enough, good enough, and you're late, so get it in the line.
Yeah, it could have been cut during development as well. Yeah. So we've got some comments on a global products. Maybe there's different SKUs, different models in different regions that have different antennas. Which one is the bottom antenna down there? Was
Bluetooth.
that was the Bluetooth.
Yep.
Are there different Bluetooth frequencies in other? Yeah.
I know
It's
when I was out. Too much. Yeah. Getting interference and other things. So the really like if you're a left-handed, you might not get the greatest performance.
really?
The fact that these things are on the opposite side, that they think they were just covering your back. You know, we got to make sure that the performance is really good. How can we do that? How can I ensure that the different geographies and we'll see. One is better than the other.
Yeah. Great thoughts on the antenna. We got a few in the back, Alec. It's a proprietary. So the thought was it's a proprietary communication within Amazon. Ooh,
Not very well known.
not common. That's interesting. That went back to someone else's theory on all the Amazon devices becoming sentient. One vote in the creepy call. All right, we got just a few minutes left. We got to stay on time here. We got like another 5-10 minutes. So let us know if there's anything specific that you want us to look at here. What else do we want to go through on your side, Molly?
Yeah, I mean, I thought that these antenna clips, the grounding clips along the way, were pretty beefy. Curious if people have thoughts about why they might have to be so beefy. Just over-engineered, or what else?
Beefy antenna. Yeah, I remember most of the devices was just on the PCB. There's a little clip, a little exposed grounding point on the antennas, and you just clip it in. But these are pretty hefty screws here. To prevent failures during reliability, shock and vibe. Yep.
I think that might just be PSA down. Does that seem right? Well, I see like 2 pins, but I think it must just be PSA.
So the question was around how is the antenna board actually secured down? It's like just PSA.
Switch over.
Well, you want to
Question here around how difficult it was to get the PSA off.
Nice tool of those deterrent. But yeah, this is just some adhesive on the back of the antenna here, just stuck to the plastic part of the frame. A couple things that you may have missed while Molly was talking. Just a ton of screws. So I've been taking out screws for the last couple of minutes here. You can see all of these came out, and there's a big plate. I gotta say, I've taken apart a pair of iPads, and they're way tighter than this. I think there's an element here to it not being a portable product. You don't need a battery. You can make it beefier, you can make it heavier, and you can make it a little bit less space compact. Not quite the same as a typical tablet.
Yeah, it's kind of interesting to have a tablet that you don't carry around. That's just kind of mounted there primarily. Chris was mentioning too on the on why do those antenna clips need to be so beefy, that it's rotating around all the time, which is kind of an interesting throughout the entire life. I wouldn't think that it's getting that much shock from the small rotations, but there's also a speaker in there, and we saw it on the Sonos too. Is the speaker? They have a lot of different design features to prevent either connectors coming out or components rubbing against each other.
Right. I'm going to drop this board off. You can see there's quite a bit of thermal design here as well. And these are real tricky. But yeah, we have thermal pads on the top of each of these fuel cans. We have electrical grounding foam on every fuel can. Subsystem. Maybe it's a missing foam. No. And we have some heavy thermal paste on the back here. And just flexes and cables on the lower.
This is actually an interesting one that we were having a debate about earlier. The paste on the back is super runny. It gets super messy. You guys have probably seen this thermal paste. But then on the front side, on top of those shield cans, there's a lot of just thick thermal pads that have a similar purpose. What are the trade-offs or the scenarios where you guys have seen that really runny paste versus the more viscous kind of solid pad? Thermal paste versus pad. If it can be contained, then you use the liquid you want. All right, so if you want to keep the shape, then you use more of the pad. All right, any other thoughts over here? Yeah. Runny stuff performs better. Yeah. They have what? Diamond pads. Wow. The comment was around the trade-offs. Potentially, the runnier ones have better thermal performance, which seems like it would line up, because otherwise, if they had similar thermal performance, even in the self-contained space, you might as well use the shaped one. So I'm thinking there's a trade-off. I don't know personally what the trade-off is, but I think you're on something there.
For any of you folks playing bingo, I just obliterated this disconnect. Obliterated. Yeah.
We got like tons of bingos.
Ooh. I like this.
Wow, paste needs to be thinner because the conductivity is not great. All right, interesting. That's an interesting thought. Paste also probably accommodate a wider range of different Z stacks. If you don't know exactly what it's going to be, kind of just take up the gap with a super gooey paste. I know you guys have all done that before. Ooh, good thought. So fluctuations over time. I was thinking just during assembly, different time zero tolerances, but actually movement over time. That's an interesting one. Yes, rework. So any,
or you might like simple one
Oh, just ease of assembly. Yeah.
I might decouple them.
We also had a curing time here. All right, last thing I think our bingo has been upgraded to first dibs on drinks after this. Still applies, don't worry.
One thing I will highlight here is one of the reasons why I had some trouble with this flash. I think it's the camera flash based on already product. It was taped down forward. The only flex where it was taped down and had a zip control. It seems like one of those things you add last minute when something goes wrong. Has anyone else had issues with fluxes coming out over time?
Any last minute capped on?
In one hand, flex coming out. Flex coming out. That flex is tearing. Yeah, yeah, Alex does. All right, any final components that you want us to look at here as we're wrapping up? As a reminder, we will have all these images. Good news is we have all these images in the app. So if you're just dying to go back and look at more thermal paste tomorrow, we've got you covered. We can get you account access to this whole teardown library. You can look through this one and you have all the images from all these as well. But look at the hinge. All right.
I can show you a little bit here, but maybe Molly, you follow that up and dig in a little bit deeper.
Actually,
I know you have some experience with hinges.
I do have some experience with hinges. I'm not sure I have a picture of the hinge though.
Yeah, what?
You think that one?
You can see it pretty good. You can see it pretty good there. What kind of hinge do you think that is, Molly?
Yeah, so I mean, typically when I worked on laptop hinges, it's usually like one side is basically C-clamp, and one side is just a post or cylinder. And you're just messing with how much friction, basically how much interference you're going to have, and then putting grease in to make sure you still have a nice feel. So it looks pretty standard to me.
Yeah, I think I see what you're talking about here. You have a little nut here and some kind of spring. And then it's just kind of bottoms out of the exterior. Probably close this down and put some lubricant on it, like we said, and it feels good.
Yeah.
The question was around what is the
Is there a
spring?
spring?
I don't think there's actually a spring in there, right?
Oh, I'm not sure about this thing. It's got like a better shot of that. It's kind of curly looking thing here. But it is a little more cylindrical.
Yeah, it didn't feel like there was a spring in there. I think it must be something else. But yeah, the kind of interesting thing about hinges is the tolerance on the torque that they have, right? So it's probably like, I don't know if it was plus minus 10% or something along those lines. So you're always designing to some touch force that's going to be on the display, but making sure that even in the worst case hinge scenario, you're still going to have sufficient force, sufficient holding force. Did a lot of hinge calcs like that.
Yeah, you have to figure out what's the average pressing force of a human is.
Yes, you do. And then you might change your thought at what average was when you can't achieve it.
All right, awesome. Final questions. We'll still have this up here as we wrap up. So if you need, a few more beverages to get the final questions out, you can grab one, come over and hang out up here. Any other questions, things you want to look at before we wrap up? Oh, yes. So wrap up. We have a survey that the marketing team takes very dearly, and if you fill it out, it actually guides what we're going to tear down next. So for those online, fill out the survey. For everyone here, just go talk to them, and all complaints filed that way. We really thank you guys all for joining. This in-person thing was fun, but we want to hear your feedback. If we get enough feedback, we can do this again. Again, we're here to build a community and to learn some stuff together. So hang out. We've got beverages. I think the Warriors game is starting soon. So I know you guys. If anyone has like a YouTube TV login, we'll just put it up there. And then we can kind of combo. But thank you guys all for coming. We'll be around here. So come up.
Thanks, everyone.
Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich, remote dataset to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today